Most of the time when you're working with navigation, you'll go into some kind of detail screen as your second view. That usually means showing more information about whatever you're displaying on the main screen. In our case, we've got a list of titles, therefore, we'll navigate to a screen that shows more details like the name and description. In this video, we're going to create this detail screen. Then we'll be ready for navigation in the next one. The first step is to create a new file. Hit Command N, SwiftUI View, Next, Title, Detail, View, Create. Make some space after line 10. We want to define a title variable to build our view. Let title: make more space. Our preview needs a title argument. Click on the error, fix. We can put in title.preview titles (0). This takes the first title from our preview titles array, our sample data coming in clutch. I'll also show the canvas to help us build the view. Now we can build how the information will be displayed. Delete the famous hello world. Instead type geometry reader, geometry in. We're going to display the title image for now, but move on to a YouTube video later. Geometry reader allows us to get the size of the screen for this view. Next type scroll view with braces. Some of the titles have pretty long descriptions. In case this happens, scroll view will allow us to scroll down. Moving on, type lazy vstack, alignment and content, leading, tab, press enter for braces. This lazy vstack aligns its elements to the left of the screen and loads them when needed. Now we can declare our async image, select the one with URL, parentheses string, title.posterPath, ? quotes. We unwrap the title poster path and give an empty string in case it's nil. Add an open brace, image in, press enter a few times. After the closing brace, placeholder, progress view. This adds a nice progress circle as the image loads. Inside the async image braces, we can add modifiers, image.resizable, .scale to fit. Finally, add a .frame modifier after the closing placeholder brace. .frame, width and height, geometry.size, .width, tab, geometry.size, .height, times 0.85. This frame keeps a place for the image as it loads. With the image ready, we can show some text, double parentheses, title.name, ? title.title, ? parentheses, .bold, .font, .title2, .padding, 5. We try both the name and title first. If they are both nil, then we just leave it as an empty string. After, we apply modifiers to make it look better. I would like the title closer to the image, .padding, .top, comma, -20. Now we just need to display the description, text, title.overview, ? quotes, .padding, 5. This is a very simple detail screen, but it shows everything in the title struct except for the ID. As we move on, we'll add a download button and the YouTube video in place of the image. Fun fact, to make this screen, we had to use a little bit of everything from the course we've learned so far. Thank you for joining me. See you in the next one. Navigation is extremely important in SwiftUI. This is because you'll want users to go to different screens in your app. Currently, The latest and greatest way to achieve this is with Navigation Stack. In this video, we'll show how it works by implementing it in Blossom Movie. We're going to start by seeing how buttons can drive navigation. In our app, we have a hero title showing on the home screen. The play button is meant to take the user to our title detail screen. Right now, the title is just static, so the first step is to show a different title every time the user opens the app. Since the app is called Blossom Movie, we'll use a different title from our trending movies list. Make sure you're inside View Model. Under Top Rated TV, add a line. Type var hero title equals title dot preview bracket 0. This defines a new title called hero title. We initialize it using the first title in our sample data. By doing this, we'll have a fallback, and we'll need to unwrap it later. Scrolling down, make a couple lines after Top Rated TV. If flat title equals trending movies dot random element braces hero title equals title. This makes sure trending movies dot random element isn't nil before assigning it to hero title. We're all done here. Open home view. Delete hero test title with command delete. There's an error inside async image because hero test title doesn't exist anymore. Replace hero test title with view model dot hero title dot poster path question mark quotes. Poster path is an optional, so we do need to unwrap it. Just an empty string works for now. The picture will just be a progress view if nil. Press Command R to run. Nice, the title changed. I'll close and reopen the app to make sure it changes each time. Keep in mind, we're getting a random title from trending movies. Therefore, we might have some repeats. Step 1 is complete. Now we can get into the navigation. After we define our view model, type add state, private, var, title, detail path, equals navigation path. Add state means the UI can change this variable. Navigation path helps us manage where the user goes in our app. I'll close the log. Now we can embed our geometry reader in a navigation stack. Make sure your canvas is open so we can use a shortcut. I'll adjust the canvas. Right click on geometry reader, embed, navigation stack, parentheses path, colon, $, title detail path. Navigation stack starts with your main screen and lets you navigate to new ones, kind of like stacking pages on top of each other. Path, $, title detail path tells SwiftUI which screens we visited, so it knows where to go and how to go back. Moving on, inside the play button action, we can put title detail path dot append view model dot hero title. This adds a new screen to the stack using hero title as the data for that screen. We do get an error because our title struct doesn't conform to hashable. To fix, open title.swift. After identifiable, put a comma. Hashable. Hashable lets Swift tell if two items are the same. This is required when using navigation path. Let's go back to home view. And the error is gone. We can close the canvas. The last thing we need to do is add a navigation destination. Find the closing brace of our lazy V stack. Make some space. Dot navigation destination. Select for destination, title.self, tab, enter, title, tab, title detail view, title, title. This tells SwiftUI, when we push a title onto the stack, show the title detail view with that title. It's how SwiftUI knows what screen to show when we use dot appending with the title. Hit Command R to test. Alright, our app is ready. Let's press the play button. Nice, it works. We can scroll down for the rest of the description. Our layout isn't the best. That's what I get for listening to the canvas and not testing. It's an easy fix. Open title detail view. Delete the negative padding. Run it again. Now press play again. Much better. That's all for this video. Thank you for watching. There's a good chance you'll be showing some kind of list in your app. When an item of that list is tabbed, it's common to navigate to another screen, passing the item data. In this video, we'll show how to achieve this using navigation paths. We want to keep the navigation logic inside home view. To do this, the tabbed item needs to be accessible here. Open horizontal list view, press enter on line 12, type let, on select, title, return arrow void. On select is a closure property that takes a title and returns nothing. The title we pass will be accessible to home view, allowing it to handle navigation. Keeping that logic inside the parent view helps prevent nasty bugs. Now we need to pass the tab title to our onSelect property. The best place to do this is right before the for each loop ends. Here, we still have access to the title that was tabbed. Click the end of our dot frame modifier, make a new line, dot onTab gesture, onSelect, title. We just need to fix our preview. Scroll down. After the closing parentheses, open brace, title in, press enter a few times. This tells a preview, do nothing with the tab title. With this completed, we can go back to home view, scroll down. We have some errors to fix due to our new onSelect property. After the closing parentheses, add an open brace, title in, enter times 2, inside the braces, title detail path, dot append, title. As a quick reminder, title detail path is a navigation path we defined on top. Dot append puts our tab title struct into the title detail path. This allows it to be displayed in title detail view, defined below with dot navigation destination. We just need to fix the other 3 horizontal list view errors. Let's copy the closure we used with trending movies. Paste it for the next 3. Always good to save some time. Before we test, we can cut our dot navigation destination modifier. Paste it right under our dot task modifier. It's good practice to have this modifier as close to the navigation stack as possible. This helps us see the navigation more clearly. Go ahead and run the code with Command R. Let's click on our first trending movie. Nice, it works. Let's go back and do some more testing. I'll just click on a few. Good. We're able to click around and go back to our home screen. Let's also make sure the hero play button works. Do it a few times. No issues here as well. A slightly shorter video, but if you're not careful, nasty bugs happen with navigation. These can include duplicate screens and views not being dismissed. That's it for this one. Thank you for watching. You might want to display a web page or maybe a YouTube video in your iOS app. WebKit is a perfect tool to help accomplish this. This is a UIKit tool, and at the time of this recording, there's no native way to do this in SwiftUI. In this lesson, we'll set up a web view to display a YouTube video. This will get us one step closer to fetching and displaying trailers for each title. Before we get started, I want to point out it's not a good idea to keep sensitive information directly in the client. For production apps, Firebase Cloud Storage or a secure backend would be a safer option. However, this is a practice app that won't be published. The goal here is to focus on learning and get better with SwiftUI. With that out of the way, let's open our API config.json file, add a comma after tmdb API key, enter, type parentheses YouTube, base URL, parentheses colon, parentheses https colon youtube.com/embed. This will be the URL we use to show our YouTube videos. Next, open API config.swift. After tmdb API key, press enter. Let YouTube base URL colon string. This gives us access to the YouTube base URL string throughout our app. Please make sure your spelling matches with mine before moving on. Make a new file with Command N, Swift file, next, YouTube, player, create. We don't need import foundation here and can replace it with import SwiftUI. Also add import WebKit, add a couple lines, type struct, YouTube, player, colon UI, view representable, with braces. UI view representable lets us wrap a UIKit view and use it inside SwiftUI. Inside the braces, type let web view equals UK web view, enter, let video ID colon string, enter, let YouTube base URL equals API config.shared.YouTube base URL. UK web view creates an instance of a web browser, but inside the app, we'll use the video ID and YouTube base URL to load our videos inside it. Make some space and type func, make UI view context, return arrow sum view UI view. Inside the braces, type web view. This function is part of the UI view representable protocol. It's called once our SwiftUI view is created and tell SwiftUI, this is a UI kit I want you to use. In our case, show the web view we just made. Down arrow once, add a couple more lines, func, update UI view type, context with braces. Another part of the UI representable protocol. This one gets called whenever SwiftUI updates the view. We'll load our video here into the web view. Inside the braces, type guard let base URL string equals YouTube base URL, comma, enter, let base URL equals URL, parentheses string, base URL string, else, bracket, return. This first unwraps the YouTube base URL string from our API config, ensuring it's not nil. Then we convert the string into a URL, also making sure it's not nil. If either of them are nil, we safely exit the function. Below that, add let full URL equals base URL dot appending path video ID. Enter web view dot load URL request parentheses URL full URL. We complete our YouTube URL by appending the video ID. Then we have WebView load this URL. This completes the file. Let's now open title detail view. Delete async image. Add YouTube player, video ID. Paste this ID in there. It's one of our most popular YouTube shorts. Add the modifier dot aspect ratio. Select aspect ratio and content mode. 1.3 for aspect ratio. Tab dot fit for content mode. This modifier makes sure the video keeps the correct shape and scales proportionally. 4:3 or 1.3 is the YouTube Classic embedded video ratio. Hit Command R to run. The simulator is up. Click on any movie title. Perfect. We have our web player showing front and center. Press play. Need an SF symbol, and it works. Right now, all the titles will have the same video, but the next step is to work with the YouTube API to get the trailers for each title. Thank you for watching this video. See you in the next one. Google, along with Apple, is one of the main forces in the mobile development space. As an iOS developer, there's a good chance you'll use a Google product at some point. This could take form with Google Auth, Firebase, or Google API. In this video, we're going to start working with the YouTube API. This includes getting our API key from the Google Developer Console, as well as modeling the return JSON data. The first step in our journey is to get our credentials. Open your favorite browser, type Google Developer Console in the search bar, open the first link. If you haven't already, please make yourself a Google account. Once you have one, click on Create Project. I'll call this project Blossom Movie. Create. With the project created, navigate to Library. Find YouTube Data API v3. Open it. Enable. Now we just need to create credentials. We're going to be using public data. Next. We have our key ready to go. Go ahead and copy it. Let's go back to Xcode. Open api-config.json. Put a comma after YouTube base URL. Enter. Parentheses YouTube. API key. Parentheses colon. Double parentheses. Please paste your API key in here. I'm going to put in your key as a placeholder. While we're here, we might as well define the YouTube search URL. Add a comma after the YouTube key. Enter, parentheses YouTube, search, URL, parentheses colon, parentheses. I'll paste the URL here to save some time. It'll be in the description if you want to grab it. With our new properties in the JSON file, we just need to define them in api-config.swift. Make a new line after YouTube base URL. Let YouTube API key colon string. Enter. Let YouTube search URL, :string. Please make sure your spelling matches with mine before moving on. The next step is to model our JSON data. I'll bring up an example of what a YouTube search call returns. This is the data we're working with. We're going to conduct a YouTube search on the title name and the word trailer. The only element that interests us here is video ID inside the items array. This video ID will be passed to our YouTube player to show the trailer. We'll simply use the first ID as it's most likely to be the correct video. Let's head back to Xcode. Command N for a new file. Swift file. Next. YouTube. Search. Response. Create. I find it easier to start from the bottom when modeling a nested dataset. Struct. ID. Properties. :codable. With braces. Let. Video ID. :string. ? This models the last layer, getting our video ID. It's a good idea to make these properties optionals in case the database returns nil. We can go to the next layer up, which is an object named ID. Make room at the top of ID properties. Struct. Item properties. :codable. Let ID : ID properties ? We just need the top layer. Struct. YouTube search response : :codable. The top layer has an array that contains item properties. Therefore, we can type let items : bracket item properties bracket ? The struct names themselves don't matter as much as the property names. Property names have to match the JSON data or else the app will crash. I'll bring up our working data one more time. Starting from the top, we have an array of items that contains an object called ID. Inside ID, we're able to get the video ID. We're all done here. Everything is set up, and the next step is to parse the data. Thank you for watching. Something about programming is that although rewarding, it tends to be a bit repetitive. For example, in our app, we already saw how to model an API response, build a URL, and parse the response. In the pursuit of working with the YouTube API, we already modeled the response. Now we must complete the next two steps, building the URL and parsing. This will be the main topic of this video. It's good to remember that practice does make perfect. To start, open datafetcher.swift. We need to define our new variables under TMDB API key. Let YouTube search URL equals API config.shared.YouTube search URL. Enter. Let YouTube API key equals API config.shared.YouTube API key. To recap, our end goal is to show the YouTube trailer for each title in the details screen. By using the YouTube API, we can get the trailer video ID and pass that in the YouTube player we made earlier. Now we can create a function to build a URL and parse the data. Scroll all the way down, click after the second to last curly brace, hit enter a couple times. We'll make this its own function since it's a different API. Func fetch video ID parentheses for title :string close parentheses async throws return arrow string. This function takes in a string called title. It also makes a network call and could throw an error, therefore async and throws are needed. The function returns a string at the end. Inside the braces, we need to first unwrap the YouTube URL and key, guard let, base search URL equals YouTube search URL, else braces throw network error dot missing config down arrow, enter twice, guard lat, search API key equals YouTube API key, else braces throw network error dot missing config. The next step is to build our URL. I actually want to show a different way to accomplish this without hard coding like we did in the movie database. Open constants. Right after the closing brace, make some space and scroll down. Enum, YouTube URL string, :string with braces, case trailer equals parentheses trailer, case query shortened equals parentheses q, case space equals parentheses space, case key equals parentheses key. Using enums this way to group related strings helps prevent typos, encourages reusability, and keeps things neat. I wanted to show a better way than just hard coding the values. I used this method in another project and it's been pretty good. It should actually be YouTube URL strings. Going back to data fetcher, under search API key, let trailer search equals title plus YouTube URL strings dot space dot raw value plus YouTube URL strings dot trailer dot raw value. This is one query we'll make to the API. Make some space. Time to finally build our URL. Guard lat fetch video URL equals URL parentheses string base search URL dot appending query items URL query items. Press enter. After the first bracket, press enter. Press enter again after the closing bracket. This spaces it out, making it easier to read. We can now add our query items. I'll scroll down a bit first. Add a parentheses after URL query item. Select name and value. For name, YouTube URL strings dot query shortened dot raw value tab trailer search. Right arrow, add a comma to add another query item. Press enter first for better spacing. URL query item, name and value, YouTube URL strings dot key dot raw value tab search API key. We just need to complete the guard let statement. After the closing parentheses, else with braces, throw network error dot URL build failed. After we build the URL, add print fetch video URL. This will help us check the URL in the console. To help us see this more clearly, I'm going to paste the URL that we just built using Breaking Bad as an example. The first part is our base URL. We then add our first query represented by the queue and the trailer search string we built. The second query is our API key. I did want to tackle parsing in this video, but I actually think this is a good place to stop for now. Thank you for watching. Parsing API JSON responses is one of those things that keeps coming back. We've already seen how to do it with the movie database, but this time, we're taking it a step further. In this video, we're going to refactor that code and make it reusable using Swift generics. With the refactored code, we'll be able to parse our YouTube API response. We can open Data Fetcher to start. Parsing the response in our fetch titles function starts from let data URL response till var titles. This code will be similar to parsing the YouTube response, the only difference being what object we return. We could just copy and paste the code down to our fetch video ID function. However, this is the perfect moment to introduce Swift generics. This can also be good code for later projects. Let's make some space after the fetch title closing brace. We'll make the function here first, test it, then call it for the YouTube response. Func fetch and decode, left arrow t colon decodable, right arrow, parentheses URL colon URL, comma type colon t dot type, parentheses async throws, return arrow t with braces. T colon decodable lets the function know that the struct we're working with must conform to decodable. We pass in two arguments, a URL and a struct using t.type. T.type means we're passing a generic struct that we want to decode, like API object.self. The function will perform a network request and can throw an error, which is why async and throws are needed. Finally, it will return a struct represented by t. Select from let data URL response to var titles, cut with Command X, paste it inside our fetch and decode function. We just need some adjustments. Replace fetch titles URL with URL. Delete var titles equals at the end. Replace with return. API object should be t.self. Finally, delete .results. We replaced our hard-coded values with the arguments we passed into the function. Here's a quick recap of what this code does. We use try await URL sessions that share that data to fetch data from the URL passed into the function. This gives us both data and a URL response. Then, we unwrap the response and make sure it's a HTTP URL response with a 200 status code. If it's not, we throw a custom next step error that describes what went wrong. After that, we define a JSON decoder and tell it to use .convert from snake case. This is needed since our JSON keys are snake case, but our Swift structs use camel case. Lastly, we use that decoder to try and return the object type t from the URL data. T is the generic type we pass into the function. We can actually replace this with type since we already defined the variable. Now we just need to call this function and fetch titles. Click under print fetch titles URL, var titles equals try awaits, fetch and decode, fetch titles URL, API object.self, .results. Going back to title.swift, remember that API object has a variable called results, and that's where the titles live. I think a rename is in order because we're now working with two APIs. Right-click API object, refactor, rename, add tmdb at the front, enter. Navigate back to datafetcher.swift. To clean up our struct a bit more, let's move the helper functions to the end. Select fetch and decode, and build URL. Command X, paste them under fetch video ID. The final step is to use our new function to finish fetch video ID. Select after the print statement, make some space, return, try, await, fetch and decode, fetch video URL, YouTube, search response, .self, .items, .first, .id, .video ID, question mark, quotes. We pass in the YouTube search response struct this time. Remember, this struct is pretty nested. It returns a list of items, so we grab the first item in the array. From there, we drill down to video ID, chaining each level with a question mark to safely unwrap. If anything in the chain is nil, we return an empty string using a double question mark operator. We're done with parsing the API responses. The fetch video ID func isn't hooked up anywhere, but we can still test to make sure our new function works for fetch titles. Please update your TMDB key inside API config.json before running. Hit Command R. Our simulator is up and everything loaded correctly. Click around to make sure everything is working. Good job with this. In our app so far, we've done a lot of legwork to get the YouTube API going. After modeling, URL building, and parsing, all that is left is to hook everything up. Although slightly controversial, we'll be using model, view, view model to get everything up and running. Lucky for us, we've already built the MVVM structure in our app. That was the hard part. Adding more logic is much easier. Open viewModel.swift. Press enter after the home status enum. We'll make a new enum to keep track of the video ID fetch state. Private. Set var video ID status :fetch status equals .not started. Let's press enter to space it out better. Make a new line under hero title. Var video ID equals quotes. We'll use this property to hold the string that our YouTube API fetches. Find the closing get titles brace. Press enter a couple times after it. Func get video ID for title :string async with braces. This function will be called in the UI to retrieve the video ID. We can set the status to fetching when called. Video ID status equals .fetching. Create a do catch block under that. This will help us handle errors. Inside do, we can call the API video ID equals try awaits data fetcher .fetch video ID for title. Video ID status equals .success. We set this if everything goes well. Inside catch, we can print the error to our log. In addition, set the status to .failed. Don't forget to pass the error for underlying error. This completes the view model. All that's left is to hook it up to our UI. Open title detail view. There are a few things I want to do here to make our code better on top of adding the feature. To start off, let's create a computer property of our title name. Make a new line after title. Var title name :string with braces. Inside the braces, type return parentheses title.name title.title parentheses quotes. This is the first time we've seen computed properties. It's a great way to add custom logic to your models without storing extra data. This logic tries to return the name or title first. If they are nil, an empty string is returned instead. Our API uses names for movies and titles for TV shows, so we test for both. Under this computed property, make a new line, let viewModel equals viewModel. Our viewModel will control the UI depending on the API call result. Find the closing brace and scroll view. From the closing brace to the open brace, press Command X to cut. This code will be used if the call succeeds. Inside the geometry reader brace, type switch viewModel dot video ID status. Xcode completes the cases for us. Inside .NotStarted, put empty view. We can tab over. .fetching will just show a progress view. Add a line and add .frame, width and height. For width, geometry.size.width, tab, geometry.size.height. This puts the progress view in the center. Inside case.success, paste the UI code we cut. Replace video ID inside the YouTube player with viewModel.videoID. We can also use title name inside text. Finally, inside case.failed, type text underlying error.localized description. For now, we just show what error took place, but we'll make this more user-friendly later. The last thing to do is to call a viewModel to fetch the video ID. After the geometry reader brace, make a new line, .task with braces, await, viewModel.getVideoID for title name. Before we test, please make sure you update your API keys in API config.json. Hit Command R to run. The app is ready. Click on the play button from the hero title. Nice. The video loads, and it looks like it grabbed the correct trailer. Press play. And it works. Go back. Let's try a trending TV title. Perfect. Also looks great. Just a heads up with the YouTube API. Google limits the API calls per day. If you open enough titles, you'll get an error at some point. That's it for this video. Thank you so much for watching. With making iOS apps, there's a good chance you'll need different style of list. We already saw how to make a horizontal list. In this video, we'll make a vertical list in SwiftUI, expanding our toolset. Let's start by making a new file with Command N, SwiftUI view, next, vertical list view, create. Click on line 10, enter. We can define an array of titles to use for the list, var titles, :bracket title. We get an error because the preview needs a list of titles to use. Select the error, fix, pass title.preview titles. Make a new line after titles. Delete the famous hello world. List, parentheses titles, parentheses bracket, title in. Inside the list braces, async image, URL, parentheses string, title.posterPath, question mark, quotes. We make a new list and pass our titles in. Then we show each title poster with async image by converting the poster path to a URL. Modifiers are needed on our async image. Right arrow twice, bracket image in, enter, enter. Right arrow, placeholder, progress view. This shows a progress circle as the image loads. If the poster path is nil, we pass an empty string that just keeps the progress view going. Go back in the async image brace, image, enter, .resizable, .scale to fit, .clip shape, .rect, corner radius, 10, .padding, 5. These modifiers allow the image to be resized to fit within the space given, make the corners round by a radius of 10, and add space around at 5 points. We want the title names to be next to the poster, therefore, right-click on Image, embed in H-stack. Make some space after padding 5, text, parenthesis, parenthesis, title.name, question mark, title.title, parenthesis, question mark, quotes. A title can have a name or title property depending if it's a movie or TV show. We try both, and if they're nil, an empty string is passed. Let's add a couple of modifiers to the title. .font, .system, size 14, .bold. By putting our title inside the async image closure, it won't show unless the poster loads. Click after the placeholder brace, enter, .frame, height, 150. This keeps the list items no more than 150 points tall. Since no width is specified, each item takes up as much space needed horizontally. The list looks great. We can use it in our app, but only with sample data for now. Make a new file with Command N, SwiftUI view, next, upcoming, view, create, delete hello world, vertical, list view, titles, title, .preview titles. This seems like overkill to just call this in our content view. In the future, there will be logic here that can make our content view messy. Navigate to content view, delete text contents upcoming string, replace with upcoming view. Press Command R to run. Our app is up and running. Click on upcoming. Nice. We have our sample data showing as a vertical list. We still need to add navigation and, of course, real API data. This is the first time we work on another tab in the app, so great job. We're done here. Thank you for watching. At this point in the tutorial, our vertical list is built. However, it's still only showing test data. In this video, we'll populate it using our API and display a list of upcoming movies. Open Data Fetcher. I'll paste the URL we'll populate our vertical list with. This URL is identical to our top rated URL, with the only difference being upcoming instead of top rated. We'll have to adjust our build URL function to construct this correctly. Scroll down. Inside the else if statement, type or type double equals upcoming. Replace top rated with backslash parentheses type. This will build the correct URL when top rated or upcoming are passed for the type. To make our code a bit better, delete trending in the first if statement, backslash parentheses type. The less hard-coded strings, the better. Our build URL function can now make the upcoming URL. With this, we can open our view model, make a new line after video ID status, private, parentheses set, var, upcoming status, fetch status equals .not started. We'll use this enum to keep track of the upcoming title's fetch state. A new array is also needed to hold the upcoming movies. This can be placed after top rated TV, var, upcoming movies, colon, bracket title equals empty brackets. By making this array empty, we won't need to unwrap it later. Since this call will not be on the home screen, we can make a new function for it, scroll all the way down, make some space after the get video ID function, func, get upcoming movies, parentheses async with braces. Inside the braces, we can set upcoming status equal to .fetching. Then we can make a do catch block. Inside do, upcoming movies equals try await, data fetcher, .fetch titles for movie by upcoming. Try is needed because this function can throw errors, and await allows it to run in the background, not blocking the UI. If this call completes, upcoming status equals .success. Now we just need to complete the catch statement. Print error, upcoming status equals .failed, underlying error, error. We print the error in our console for debugging, and then pass the error in our enum for the UI. Everything is ready to go here. We just need to hook it up to our UI. Open upcoming view.swift. Make a couple of lines after line 10. Let view model equals view model. Delete the preview titles. Replace with view model dot upcoming movies. Make some space before this line. Switch view model dot upcoming status. This allows us to define a view for each state. In .not started, we can put empty view. .fetching is progress view. Cut the vertical list view code. Paste it inside .success. Lastly, text, underlying error, .localized description, works great for case.failed. The progress view should be in the center of our view when it loads, before the switch statement. Geometry reader, brace, geo in. Delete the closing brace. Put it after the switch closing brace. Add a frame in progress view. .frame, width and height, geo.size, .width, geo.size, .height. This puts the progress view in the center of the screen. All that's left is to populate the data, find the geometry reader closing brace, enter, .task with braces. Inside the braces, awaits, view model, .get upcoming movies. This populates the upcoming movies array. Before running, please make sure to update your API keys inside API config.json. Hit Command R to run. Our app is up and running. Navigate to upcoming. Nice. The data populates. We can scroll down, and everything is in working order. If you're thinking, it's getting easier to set everything up, you'd be right. A lot of the infrastructure was done in section 2, allowing our new features to be added faster. That's it for this video. Thank you for watching. Navigation is a critical aspect in any app. Like most things, there are a few ways to accomplish this. We already saw one way by using Navigation Stack and Navigation Path in the home screen. In this video, we'll demonstrate how to use navigation links with Navigation Stack for the upcoming screen. To start, let's open the parent view, which would be upcoming view. We need to embed this view into Navigation Stack. Right-click on Geometry Reader, Embed, Navigation Stack. This allows us to enable navigation within our view. For example, tapping a list item can now push a new screen into the stack. The next step is to define a navigation link inside the child view. Open vertical list view. Make some space before async image. Navigation link with braces. Define a label after the closing braces. Inside the navigation link braces, we need to define our destination. Title, detail view, title. This passes the title tabbed before going to title detail view. Label defines how the navigation link is shown. The UI for the vertical list will do great. Select from async image till dot frame. Cut. Paste it inside label. To recap, we added navigation stack to the parent view. Then, we added navigation link inside the child view. Navigation link lets us define where the user goes and how the link looks using label. Please make sure the API keys are updated inside api-config.json. Press Command R to run. The app is up. Select upcoming. Notice there are arrows on the right showing a clickable list. Click on the title. The title detail view opens correctly. I'll test a few more titles. Everything seems to be in working order. Let's go to the Home tab while on a title detail in the Upcoming tab. Click on the title. Go back to Upcoming. The detail screen maintained in Upcoming. If we go back to Home, the detail screen also maintained there. I do want to talk about navigation path versus navigation link to finish the video. Although navigation link is much simpler to use compared to navigation path, it comes with a few drawbacks. First, it's a little too eager to make the views. This can happen sometimes even when an item or button isn't tapped. Therefore, performance issues can occur. Second, navigation link only works with user interaction. You can't use it to navigate after loading data or handling things like deep links or push notifications. That means no async navigation and no programming control. All that being said, navigation link does work and it's really simple to use. I think it's good for practice apps where the point is to work on other big features and keep navigation simple. However, for production apps, I would lean towards navigation path to keep performance and overall user experience tight. I wanted to show you both ways to give you more options. That wraps up this video. Thank you so much for watching. We officially finished the second tab on the app and are pretty close to completion. I can't wait to see you in the next one.